This is R.D. Sharma solution, class 12th, adjoint and inverse of matrix. Chapter is 7. Exercise is 7.1. Now we have a 3 by 3 square matrix. We have to show that A multiplied by adjoint A is a null matrix or 0. This capital 0 represent all the elements will be 0. So first we'll try to find out the adjoint A, then we'll do the matrix multiplication. I hope you remember that how to do this. The cofactor we have to find out, then we have to write that in the matrix form, and then we have to take the transpose, that is the adjoint. So I'm just marking it so that I can give you some idea about how to, just as a recall. So these values we are going to find out, and few of these I'm going to tell you. For example, C31. What will be C31? So we have to forget about those row and column where this A31 intersect. -1, 1, 3, 0 will come, and there will be -1 to the power of the I plus j, that is 3 plus 1. So -1 to the power 4 is what? It is going to be 1. Always -1 to the power odd is -1 to the power even is always 1. So let us find it out. -1 into 0, 3 into 1, you subtract it, it will be going to be -1, -3. So this is -3. Let us take one more of it. I am taking C23, and C23, it will be this row and this column where A23 intersection is there will leave, and 1 18 -1 2 will write 1 into 2 minus 18 into -1, that is going to be 20. Since we have a -1 to the power 3 plus 2 or 2 plus 3, so it will be -1 to the power 5, and -1 to the power 5 is -1. So write it negative here, -20. Okay, all of these you have to do. I just gave you an idea how to do this. So finally you will arrive at this matrix. This is still not adjoint, okay? So I'm writing that matrix just to let you know that this is the cofactor matrix. Now you have to take the transpose of this matrix. That is, row you have to make the column, and column you have to make the row. Then only adjoint A will come. So this 30 minus 20 minus 50, which is actually the row, is going to be the column. It will become the column. So I'm writing it here: 30, -20, -50, then we have 12, -8, -20, and -3, 2, and 5. So this is what? This is the adjoint. So we have to multiply A with adjoint A. Now I already told you that matrix multiplication you need to know if you need to know the adjoint A and inverse. So we multiplied it. When you multiply, you will see it will be a null matrix 0. So 0, 0, 0, 0 will come. Let me tell you again, you need to know minor, cofactor, multiplication of matrix, determinant of A. All this you need to know before doing this exercise. So this is kind of a same question. I'll just give you an idea here. So this is matrix. We have all the cofactors. Then this is adjoint A. And then that is the cofactor matrix. Transpose is adjoint A. And that will come as the original matrix which is given to you. Now this matrix we have to show that adjoint of A is thrice that of A transpose. This A raised T is nothing but the transpose, row to column, column to row. So let me just do this thrice of A transpose so that you understand what we actually need to get when we find out the adjoint A. So this is the original matrix I am writing, and first I am taking the transpose. So I am taking the transpose, row to column I am making. So all these I have written row to column, and just multiply it with 3. What do you get? -3, 6, 6, -6, this is 3, and -6, this is going to be -6, -6, and 3. So when you take the adjoint A, this is going to come exactly like this. So I'm just giving you an idea. You have to find out the cofactor matrix as I suggested. Then you have to take the transpose of that matrix, that this will come, and these two are exactly similar. Or you can say you can take thrice out of adjoint A, that is going to be equal to the A transpose, right? Find A into adjoint A for the matrix A. So this kind of question we have done already. So I'm just giving you a hint. I would encourage you to try this and have a look at the answer only when you have any problem in computation or calculation. Otherwise, please do it by yourself, because maximum you do by yourself, then only you'll be able to do in the exam, and this will be quite easy for you. Find the inverse of the following matrix. Now this is a 2 by 2 matrix. So here you will understand how to take the inverse of a 2 by 2 matrix. First of all, we need to find out the determinant. Whether determinant is 0 or not, that will decide what we have to do. So just cross multiply cos into cos, that is going to be cos square theta, and sine into sine in sine square theta. We have a negative sign, so we already have a negative sign, so minus minus will become plus. So cos square theta plus sine square theta is equal to 1. So this determinant is not equal to 1. So A is a singular matrix. Singular matrix, that means determinant is not equal to 0. Non-singular means determinant has to be 0. Therefore, this matrix, which is a square matrix, this is invertible because A is a singular matrix. So we'll try to find out the cofactor. Let me just write it here. Cos theta, sin theta, negative sin theta, and cos theta. Okay. So let me mark it here, because actually we are going to find out the cofactor, and then we'll take the transpose of the cofactor matrix. This is C11, this is C12, C21, C22. So C11 is what? Minus 1 to the power 1 plus 1, and then we leave this row and column where this C11 intersect, only cos theta will remain. Let me write it directly, minus 1 to the power 2 is 1 only, it is going to be cos theta. Now C12 we are finding. It will be minus 1 to the power 1 plus 2, and then row column we leave, we only get minus sine theta, negative sine theta. So this is minus 1 to the power 3, and that is going to be negative, negative become positive, so sine theta. C21 is minus 1 to the power 2 plus 1, and we leave this row and column where it intersects, only sine theta will remain. Now, negative 1 to the power 2 plus 1 will be negative. Okay, so it will be minus sine theta. Now we are doing C22. So this row and column leave, you just get cos theta. So minus 1 to the power 2 plus 2 is plus 1 only, so I'm not writing it. Okay, so now this cofactor matrix you have to write first. In place of C11, write cos theta. In place of C12, write sin theta. In place of C21, it will be minus sine theta, and C22 is going to be cos theta. Okay, now this is a cofactor matrix. We have to take the transpose in order to get the adjoint. Row to column, column to row, that is what. So this cos theta, sin theta will become our column. So cos theta here, sin theta here. Then this also we have to make as minus sine theta and cos theta here as a column. So this is your adjoint A. This is actual adjoint A. Now, in order to find out A inverse, the simple formula is adjoint A divided by the determinant of A. Adjoint A is already there, determinant of A we have already found out. In order to find out the singular or non-singular, that is going to be 1. So it won't affect. Anything divided by 1 will be the same. So this is your answer. Okay. So even if you divide it by 1, it will be the same. The 2 by 2 inverse this is. Now find the inverse of the following matrix. Now this will be quite easier for you because we have done a trigonometric version. Now it's simple. It's not a identity matrix, please remember, because there is the diagonal has 0, 0. Okay. So when we take the determinant, it is going to be negative 1. Negative 1 is not equal to 0. So let us take the cofactors and then take the transpose and divide it by the determinant, that is going to be negative 1. So this is the answer. Now we have to find out the inverse of this matrix. So we have this determinant A into 1 plus BC by A minus B into C. So A gets cancelled, 1 plus BC minus BC, BC gets cancelled, you get 1. So determinant of C is going to be 1. C is a singular matrix, it is invertible. Now when we take the cofactor matrix, you just take the transpose divided by 1, because the determinant will be in the denominator, adjoint will be in the numerator, and that will be your inverse. This is the final answer. Find the inverse of the following matrix. We have already done question like this. I'm just moving ahead, because this is just practice. You have to just practice again and again and again, so that you get all those things in tips, so you can do it faster. So this 17 is showing that it is a singular matrix, so whatever answer comes or adjoint comes, you just divide it by 17. Don't take it inside. Find the inverse of the following matrix. Now this is a 3 by 3 matrix. It's a square matrix. So we have a simple formula here in order to get the inverse. A inverse is nothing but the adjoint of A. So we'll take the adjoint of A and divided by determinant of A. Determinant of A. So in order to compute the inverse, let us see what is the determinant, because determinant is very important. If it is 0, then inverse have a different kind of discussion. But right now, if it is 0, not possible. So I'm just opening it using the first row, 1, 2, 3. So 1 minus 2, 3 will come, and I'm just leaving the rows and column at 1, at 2 and 3, and other things I'm writing here. So what will be the 3 to the 6 minus 1? So 5 it will be, minus 2 to the 4 minus 3 is going to be 1, 1, 2 minus 2, 2 minus 3 to the 9, this is going to be minus 7, 7 3 is minus 21, 7 3 is 21. So you get my 5 minus 23, and that is going to be negative 18. So negative 18, since it is not equal to 0, we can proceed with the inverse, because we have singular matrix. Okay, so we will find out the cofactor matrix first. That cofactor matrix will be the final one, just a step before adjoint A, because if I am writing C11, C12, C13, C21, C22, C33, C31, C32, C33, all of these cofactors you have to find out. Let me take a few of these. Let us take C11. Minus 1 to the power 1 plus 1, what will be there? Leave that row and column where 1 lies, and then we have this 3, 1, 1, 2. So let me write it here. We have 3, 1, 1, 2, and this is, see, negative 1 to the power even will always be plus 1. Minus 1 to the power odd will always be negative 1. So it will be 5 here. So let me take few more of this so that you get the idea. C22 and C32 will find out, because the 9 cofactors you have to find out, please remember. So minus 1 to the power 2 plus 2 here, minus 1 to the power 3 plus 2 here. So C22 will be positive, C32 will be negative. Now what will be inside? 2, 2, just leave the row and column with 2, 2, 1, 3, 3, 2 will come. So 2 minus, this is a 9, this is going to be negative 7. Minus 7 here. And minus 1 to the power 5, it is going to be negative. And C32. So third row and second column, just leave this, and other value just write it here. So please remember, minor plus the sign is cofactor. So we are just leaving this. We are writing 1, 2, 3, 1. 1 minus 3 to the 6. It is going to be negative 5. Negative 5, and there is already a negative sign outside. Minus 1 to the power 5 is going to be 5. So you see the values. C11 was 5. C22 is a negative 7, and C32 is 5. So I hope you will be able to find out all of these. So final matrix will be something like this, which I am writing here. This is the final matrix. I just want you to recheck it. I want you to find out each and every cofactor. Now this is the cofactor matrix. We will take the transpose of this matrix. Transpose is what? Row to column, column to row. So 5, negative 1, negative 7. This is minus 1, minus 7, and 5. This is going to be negative 7, 5, minus 1. Negative 7, 5, minus 1. Okay, this is your adjoint A, adjoint of the matrix. Now remember, we already found out the determinant. So inverse is adjoint A divided by the value, which is going to be minus 18. So if there is a multiple of 18 inside, you can always take 18 inside, but it is not required. Okay, find the inverse of the following matrix. This is also a 3 by 3 matrix. We have already seen how to do this. I explained you just now. So just go ahead with this. So you just have to find out the cofactor matrix, take the transpose divided by the determinant of the matrix, which is 27 in this case, and the final answer will come. So one more here. Please remember, there is always problem while you are doing in examination, negative sign and positive sign. What we have, so that has to be very keenly taken care. Same thing here, same kind of question. So I'll just show you the answer, and I'll just encourage you that you do it by yourself first. All these questions same. I'm just pushing forward, because the criteria and the logic and the way it should be done is same. Here also find the inverse of the following matrix. This also you have to do the same way. Take the determinant, take the adjoint, divide both of them, and then you get the inverse. Now find the inverse of the following matrix. Now same thing you have to do. Just remember, when you are doing it, there can be some formula which can be employed. The trigonometric identity or some negative and positive sign. That may be some certain error that you have to really see. Means identity you must use, a negative positive sign you have to be very considerate about this, because this cos sin alpha always creates that kind of issue. So this row I am opening, I am not writing 0 0, only 1 I am writing, because eventually it will be 0 0. So I am just writing this one. So cos alpha, here sin alpha minus cos alpha, so it is going to be minus cos square alpha. This is going to be minus sin square alpha. You can take negative outside. Sin square plus cos square is 1. So sin square plus cos square is 1. So it's going to be negative 1. Okay. So you get the negative 1 as your determinant. So I hope you'll be able to find out the adjoint. Just divide by negative 1. That means multiply inside by negative 1. Change the sign. That is. Okay. This question we are going to do in the next session. Till then, thank you so much. Take care of yourself.